going 65, 40 miles an hour south, and they start 200 miles apart from each other. What time will train A meet train B? That's what this is. Okay, systems of equations. When they talk about systems of equations, it just means that there's more than one. Okay, you've got multiple equations you are trying to solve, and there's only going to be one answer to it. And the first, we are going to have, let's see, graphing, substitution, elimination. There are 3 or 4 different ways to solve systems of equations, and we're starting with the most archaic first. Means the one that really takes the most work and probably is the longest, and that is by graphing. Okay, basically what you are doing with this, let's see if I can blow this up here. You've got these 2 linear equations, and you're just finding out what one point solves both of them. Okay? Because there's an infinite amount of answers to this, and there's an infinite amount of answers to that, but there is only one, and only one, one and only one that answer that's going to solve both of them. So, if you want the rules to this, it's pretty simple. All you have to do is this, graph, and see where the lines cross. Which means it's pretty important that you're relatively accurate. For those of you who like to draw your straight lines freehand, it's a bad idea. For those of you who don't know how to use a ruler, I don't know, still a bad idea. But it shouldn't take you long because what form is this linear equation in? Slope-intercept. So you just simply put a dot here where it crosses the y-axis, which is 3, correct? Has a slope of -7/4. 1, 2, 3, 4, 5, 6, 7. Negative means it goes this way, right? 1, 2, 3, 4. Put your 2 points down. Let's see if we can't find ourselves a line. Looks like we're drawing a blue line. We draw that line. Okay. I am a skilled professional. No, professional. I really should have blocked that picture there. Again, as accurately as humanly possible. And then you're going to want to graph the second line. We'll just go with that. Then you want to graph the second line, which falls at -3 on the y-axis, and it has a slope of -1/4. Up 1/4 down 1, 2, 3, 4. Draw your line from there. And we kind of hope that that crosses at a point, does it or doesn't it? It does. It does. And that point is right here. And you need to give me that point, which is what? 4, -4. That is the one and only solution that solves both of these linear equations.
Oh, that's easy enough.
That is very easy. Go ahead and do problem number 2, and then we have to talk about 3 and 4. I will let you do number 2. Do number 2. I'm going to lock this thing in place. I should wait, I need to write something down, but I gotta look at my book. Consistent, inconsistent. We got an answer? There we go. This is what I was looking for. What do we get for an answer there? What column? 4, -3. Is that what we got on the other one?
We have 4, negative.
This one crossed that -4, had a slope of 1/4, 1 up, 4 over. Guess it crosses right there. I'm just doing this real fast. This one crossed that +4 and a -7 for us. 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4. Crossed there. Write that down. When you get one answer, just write this down. What it means, who really knows? If you have one answer, math people call this consistent and independent. Consistent and independent. Just write that down. No more need be said than that. Because we're going to talk about these next two here on your sheet, which I don't have, which I will get. What is it here? This one. Now, there are a couple other cases. Every now and then you run across a couple that don't work out. And no need to fear on that. Do not get afraid. Just enjoy your pace. If we do this next one, do number 3. What do you end up with number 3? A few extra little squares there. If you graph number 3, -8 and a slope of -3/7. 1, 2, 3, 4, 5, 6, 7, 9. -3/7. What happens on problem number 3? Ladies and gentlemen, make you nervous? Did I do that wrong? What happens on number 3, Kayleen? Why? Because they are, what do you call that? Lines that don't cross in math are called parallels. If you run across parallel lines, okay, there is no solution, no answer, because those lines will never cross. If they're parallel, they have no solution. And those are called in the math world inconsistent lines. Don't ask me why. Remember, the other one was consistent and dependent. This one is inconsistent, no solution. So we've got 2 lines that cross, 2 lines that never cross. Guess what our third option is? Anybody? Never cross at one point. Graph this number 4, you get what? Oh look, it's in standard form. How do I solve ones in standard form? Ryan?
We'll cover up.
X, Y intercepts. Top. Did it go away? Cover up the X, Y equals -3. Cover up the Y, X equals -1. So I graph that real fast. So that's a good looking graph. If you graph the other one,
It's the same thing.
crosses at -3 on the y-axis and -1 on the x-axis. So your other choice is, Logan, what's my other choice? the lines end up being the same line. Guess what your answer is when it's the same line? Remember, you are looking for answers that fit both equations. If they end up being the same line, what will the answer be?
Independent.
No, it's infinite solutions. You gotta say it loud enough for the teacher to hear you if you want credit for it. Which means any point on this line, and these lines go at forever in both directions, you give the range and domain. You can't count the number of solutions because this would be a solution, this would be a solution, this is a solution, any place on there is a solution. And in math, we call that consistent and dependent, if you're looking for the words. Consistent and dependent. The other one is independent, this one is dependent. Did you spell that right? Consistent and dependent. I did. So just make sure you have that in your notes at some point. So your choices are either they cross in one point, they never cross and are parallel, or they end up being the same line. And you get different answers for each of those problems. Confusion's good. There's the coughing I so missed in the last